Hello everyone, welcome to my YouTube channel. In this video we will learn how to plot the data that is generated from a for loop against the iterative parameter. So we will use Mathematica for this purpose. So let's move on towards Mathematica. Here I have written this as short code for this for loop. First of all, I have defined an empty list for this G, and then we are using this for loop where this initial velocity is 1, this time is taken as 0, the value of the acceleration is 3, and then this t is an iterative parameter which is less than or equal to 6. And then we give a command to Mathematica, then the increment of this iteration should be plus 5. And then we are generating the data from this equation, which is s is equal to vit plus half at square. We are using these semicolons and then we append to G and S. So when we use this command append to G and S, it means all the data regarding this G which has been generated from this equation S should be stored in this empty list. So if I write this G with enter shift, you will see that all the data that has been generated from this for loop has been stored in this empty list G. Next, we will generate a table of values for this equation where t is given as. So we have to make a table of these t values. So the list should be for t, and this t should start from 0 to 6, and then there should be an increment for these values which is 0.5. So if you shift enter, you will see the values of t starts from 0 and then ends at 6, and the increment between these values are the difference between these values is 0.5. Next, we will generate a list of all these values. In order to generate the list of these values, we can use a command in Mathematica which is so called thread. So you have to write this thread in curly brackets. First write without curly brackets. So let's say this is values of x and g. So you see, to create a thread we have to write them in curly brackets. So here you see that the list has been generated from these t and g values. So let's plot this list. For this purpose we can use this command list plot, and then here is the list. And so if you plot this list, you will see that these are the values. So in order to make them more obvious, so joined true, you will see that all these values are joined. So this is how one can use all the data that has been generated from the for loop, and this data that has been generated from the for loop has been plotted against this iterative parameter. So you can see that so on the x-axis this is t, which varies from 1 to 6, and on the y-axis we have taken this value g. So in order to, you can just label these x's. So this is x's. So one way is to label them automatically. So if it doesn't label it automatically, so we can label them randomly. So this is our x-axis, which is t, and then this is our y-axis, which is g. So here you see these are labeled. So in order to make it more beautiful, you can write as plot style. This is plot style. So you can make it red. This is red. Even though you can make it red and then arrow, you can write it in curly bracket. If you want to make it dotted, you can write this dotted, so the plot will be dotted, and then you can close it in some frame. So this is frame 2, and furthermore you can give color to this frame. So this is frame style, goes to this directive. So this can be red, and that's so here you see. And even though you can change the style of this frame from red to whatever you want. So let's say if we want this as cyan, so you can write this as cyan. So this is the cyan color of your, so it is not obvious, we will make it blue. So this is how we generate the data that has been generated with the help of the for loop for this equation of motion with respect to the iterative parameter, which is the time. So on the y-axis we have seen this function, and then on the x-axis you can see the iterative parameter, which is t. If you like my video, do subscribe to my channel. Thank you so much. See you in the next video. Goodbye.